In the sunlit fringe of the cosmos, Earth sings a melody while mining the rays. A cosmic dance of celestial fragments, woven into our tale at the crossroads of time. Embarking on an infinite adventure sparked by stars showering down. Seeking the clues of the universe, we set forth, carrying dreams in our hearts. A tiny part of the Milky Way, where suns and planets scatter far and wide. Born from the primordial dance, we, the precious children of the cosmos. As Earth's essence radiates amidst the azure undulations. Unveiling new doors in the enigma of the universe, transcending boundaries. On the challenging cosmic journey, the future perched on Earth's shoulders. Guided by the whispers of the stars, eternal wanderers drifting through space. Our roots deeply planted in the cosmic embrace. In the radiant glow of the sun, we script a new narrative. Oh, universe, as we dance with you. Our existence trembles to the celestial hymns. From the solar system, our odyssey commences, our lives become the universe's verse. Our stories echo as a song flowing from the boundless cosmos. Hello, today, let's embark on a journey exploring humanity's quest towards the solar system and beyond, delving into the challenges we face and delving deeper into the Sun, Mercury, and Venus. Your subscriptions, likes, and notification settings greatly empower our video production. Hello, I'll provide a detailed explanation of the solar system. The solar system refers to a system composed of the Sun, a G-type main sequence star at its center, and celestial bodies gravitationally bound to it. The constituents of the solar system include Sun, the central star of the solar system, accounting for 99.86% of the total mass. The Sun undergoes nuclear fusion, converting hydrogen into helium, and emits tremendous energy and light. Planets, 8 planets orbit the Sun. They are categorized into inner, terrestrial planets, Mercury, Venus, Earth, Mars, and outer, gas giant planets, Jupiter, Saturn, Uranus, Neptune. Terrestrial planets, Mercury, Venus, Earth, and Mars have solid surfaces. Mercury and Mars have thin atmospheres, while Venus and Earth have thick atmospheres. Earth is unique for having liquid water and supporting life. Gas giant planets, Jupiter and Saturn are mainly composed of hydrogen and helium, while Uranus and Neptune contain water, ammonia, methane, and other compounds. Gas giants have thick atmospheres, and distinctive ring systems. Dwarf planets, celestial bodies similar to planets but smaller, and haven't cleared their orbits. Examples include Ceres, Pluto, Haumea, Makemake, and Eris. Asteroids, small celestial bodies with planet-like properties but irregular shapes. Asteroids are found in the asteroid belt between Mars and Jupiter, the Kuiper belt beyond Neptune, and the scattered disk. Comets, small bodies made of ice and dust that develop tails when approaching the Sun. Comets originate from the Oort cloud or the Kuiper belt and orbit the Sun. Moons, satellites, natural satellites that orbit planets or dwarf planets. The largest moon is Ganymede, which orbits Jupiter. Meteoroids, small, burning celestial bodies entering a planet's atmosphere are called meteoroids. They can originate from asteroids or comet fragments. The formation and evolution of the solar system began approximately 4.6 billion years ago. It originated from a massive cloud of gas and dust in the central region of our galaxy. Gravity and rotation caused this cloud to contract and spin, forming a disk. The Sun formed at the disk's center, while planets and other celestial bodies formed in the outer regions. The early solar system experienced significant collisions and changes, influencing the size, shape, orbits, rotation, atmosphere, and surfaces of the planets. Hello, I will introduce the history and exploration of space probes. A space probe is an unmanned spacecraft created by humans to explore outer space. Space probes study various celestial bodies in the universe, including Earth's orbit, the Moon, planets in the solar system, asteroids, comets, dwarf planets, and even phenomena like wormholes. They collect information on the origin and structure of the universe, its physical properties, and the potential for the existence of life. The history of space probes began on October 4, 1957, when the Soviet Union launched Sputnik 1, the world's first artificial satellite. This event triggered the space race between the United States and the Soviet Union. On January 2, 1959, the Soviet Union launched Luna 1, which entered solar orbit, becoming the first spacecraft to reach the vicinity of the Moon. Luna 2, launched on September 12, 1959, became the first artificial object to impact the Moon's surface. In the 1960s and 1970s, both the United States and the Soviet Union launched various space probes to explore the Moon and planets in the solar system. Notable missions include Ranger 1, which captured detailed images of the Moon's surface in 1961, and Mariner 4, which approached Mars in 1964, providing images and measurements of its atmosphere and magnetic field. The 1969 Apollo 11 mission marked the first human landing on the Moon, with astronauts Neil Armstrong and Buzz Aldrin walking on its surface. Apollo 12, launched on November 10, 1969, collected lunar material and met the unmanned Surveyor 3. In the 1970s, both superpowers launched probes to explore the outer planets. Pioneer 10, launched on March 2, 1972, approached Jupiter, studying its atmosphere, magnetic field, rings, and moons. Pioneer 11, launched on April 6, 1973, approached both Jupiter and Saturn, providing valuable data on their characteristics. In the 1980s and 1990s, other countries joined space exploration efforts. France launched Vega 1 on October 6, 1981, which approached both Mars and Halley's Comet. Japan launched Sokigaki 1 on January 8, 1985, to study Halley's Comet. The European Space Agency, ESA, launched Giotto 1 on July 2, 1985, which approached Halley's Comet. In the 2000s and 2010s, the United States and the ESA, among others, continued to explore various targets in the solar system. Mars Odyssey, 2001, Mars Express, 2003, Spirit, 2004, Cassini-Huygens, 2004, New Horizons, 2006, Curiosity, 2011, and Rosetta, 2014, are some of the missions that explored Mars, Saturn, Pluto, and comets. In the 2020s, China, India, the UAE, and others launched space probes. Notable missions include China's Tianwen-1, 2020, and Change 5, 2021, the UAE's Hope probe, 2020, and NASA's Perseverance, 2020, and Ingenuity, 2021, missions to Mars. Space probes contribute significantly to humanity's understanding of the universe, providing crucial information on its origin, structure, physical properties, and the potential for life. These remarkable technological achievements realize human dreams and aspirations in exploring the cosmos. The Sun is a star located at the center of the solar system, and it is the closest star to Earth. The Sun emits light, heat, and solar wind into the space between all the planets, moons, comets, and asteroids in the solar system, exerting gravitational dominance and controlling their movements through universal gravitation. The Sun is a hot and massive ball of gas, with a core temperature of about 15 million Kelvin, while its surface temperature is around 6,000 Kelvin. With a diameter of approximately 1.39 million kilometers, the Sun is about 109 times larger than Earth and has a mass of 2 times 10 to the power of 30 kilograms, making it approximately 333,000 times more massive than Earth. Its volume is also about 1.44 million times that of Earth. Consequently, the Sun accounts for about 99.86% of the total mass in the entire solar system. About 75% of the Sun's mass consists of hydrogen, and the remaining 25% is primarily helium, with less than 2% composed of heavier elements like oxygen, carbon, neon, and iron. The Sun undergoes nuclear fusion reactions in its core, converting about 4 million to 6 million tons of hydrogen into helium per second, releasing tremendous energy and light in the process. The Sun's hot corona extends continuously into space, generating the solar wind, a stream of charged particles that reaches approximately 100 astronomical units, forming the heliosphere. The heliosphere is a bubble-like structure created by the solar wind in the interstellar medium, and it is the largest structure within the solar system. Although the Sun emits white light, it may appear yellow on Earth due to atmospheric scattering, especially the blue light. The Sun is located about 93 million miles, 1 astronomical unit, away from Earth, but its distance varies throughout the year due to Earth's elliptical orbit. It takes approximately 8 minutes and 19 seconds for light to travel from the Sun to Earth. The Sun has an absolute magnitude of plus 4.83, but due to its proximity, it appears very bright with an apparent magnitude of minus 26.74. The Sun orbits around the center of our Milky Way galaxy at a distance of about 24,000 to 26,000 light-years and completes a revolution roughly every 225 to 250 million years. Formed around 4.6 billion years ago, the Sun is currently a main sequence star, and it is expected to remain as such for about another 5 billion years. After that, it will expand into a red giant, shedding its outer layers to form a planetary nebula, and eventually contract into a white dwarf. Mercury is the closest planet to the Sun in the solar system, positioned at an average distance of about 58 million kilometers from the Sun. With a radius of 4,879 kilometers, Mercury is only 0.383 times the size of Earth, making it the smallest planet in the solar system. As a terrestrial planet, Mercury's surface is composed of rocks and impact craters. Due to the Sun's gravitational pull, Mercury has an extremely short orbital period of 88 days and a rotation period of 58 days. Mercury has nearly no atmosphere, and its surface temperatures are extremely extreme, reaching 700 K during the day and dropping to 100 K at night. The planet possesses a weak magnetic field and a sparse atmosphere formed by solar wind, resulting in a tail. Structurally, Mercury is the densest planet in the solar system, comprising an iron core, a silicate mantle, and a rocky crust. The core constitutes 42% of the total volume, and is believed to be in a molten state. Being the least inclined planet, Mercury experiences minimal seasonal variations. Owing to its proximity to the Sun and short orbital period, observing Mercury from Earth is challenging. It is visible only during the morning or evening when close to the Sun and exhibits phenomena like elongation and greatest eastern elongation when farthest from the Sun. Mercury has been a challenging target for exploration, with only 3 spacecraft visiting it so far. The Mariner 10 mission in 1974 and 1975 conducted 3 flybys, capturing images of 45% of Mercury's surface and measuring its atmosphere and magnetic field. The Messenger mission, launched in 2004, performed 3 flybys from 2008 to 2009 and orbited Mercury from 2011, imaging 100% of its surface and studying its atmosphere, magnetic field, and internal structure. The joint European Space Agency and Japan Aerospace Exploration Agency project, Bepi Colombo, launched in 2018, is set to enter Mercury's orbit in 2025 for further exploration. Venus is the second planet in the solar system, located at an average distance of about 58 million kilometers from the Sun. As a terrestrial planet, Venus shares similarities in size and structure with Earth. However, its surface is extremely hot, with high pressure, and its atmosphere is primarily composed of carbon dioxide. The surface temperature of Venus is approximately 462 degrees Celsius, making it the hottest planet in the solar system. Venus has a very short orbital period of 88 days and a rotation period of 243 days, with a unique retrograde rotation, opposite to the direction of its orbit around the Sun. This results in a day on Venus being longer than a year on Earth, and the Sun rising in the east and setting in the west. With almost no atmosphere, Venus has a surface dominated by rocks and impact craters. About 96.5% of its atmosphere consists of carbon dioxide, while the remaining 3.5% is mostly nitrogen. Venus's thick atmosphere creates a greenhouse effect, trapping solar radiation and elevating temperatures to extreme levels. The atmospheric pressure on Venus is about 90 times that of Earth. Being the densest planet in the solar system, Venus has an internal structure comprising an iron core, a silicate mantle, and a rocky crust. The core occupies 42% of the total volume and is thought to be in a molten state. Venus has minimal axial tilt, resulting in almost no seasons. Observing Venus from Earth is challenging due to its proximity to the Sun and short orbital period. It is visible either during the morning or evening when near the Sun and exhibits phenomena like elongation and greatest eastern elongation when farther from the Sun. Venus has been a difficult target for exploration, with 3 spacecraft having visited it so far. The Mariner 10 mission in 1974 and 1975 provided images of 45% of Venus's surface, measuring its atmosphere and magnetic field. The Messenger mission, launched in 2004, conducted 3 flybys and orbited Venus from 2011, imaging 100% of its surface and studying its atmosphere, magnetic field, and internal structure. The joint European Space Agency and Japan Aerospace Exploration Agency project, Bepi Colombo, launched in 2018, is set to enter Venus's orbit in 2025 for further exploration. As the wheel of fate spins, a journey captivated by the mysteries of the universe. The blue waves of Earth, the red landscapes of Mars, the dark mysteries of the Kuiper Belt. To where the dazzling starlight of Centauri leads, the close encounter with Proxima, the secrets of the vast world. Stories unfolding in the unknown of the universe, the courage to explore across time and space. The sound of the universe sung by the stars, a glimmer of hope shining in the dark universe. In the grand library of the mysterious universe, endless exploration unfolds, and our dreams bloom within. Hello, I will briefly explain about the Earth and the Moon as part 2 of the Introduction to Astronomy, Solar System. Subscriptions and likes are a great help in producing videos. The Earth is the 3rd planet in the solar system, located an average of 150 million km from the Sun. Earth is a terrestrial planet, with about 71% of its surface covered by water. The Earth has a revolution period of 365 days and a rotation period of 24 hours due to the Sun's gravity. Earth has an atmosphere, and the surface temperature varies from -89 degrees Celsius to 58 degrees Celsius. Earth has a weak magnetic field, and a magnetosphere formed by solar wind. Earth has differentiated into a high-density metallic core made of dense materials. The core of the Earth occupies 17% of the total volume and is divided into an inner core and an outer core. The inner core is solid, and the outer core is liquid. The mantle of the Earth occupies 84% of the total volume and is divided into the upper mantle and the lower mantle. The Earth's crust occupies 1% of the total volume and is divided into continental crust and oceanic crust. Earth is a planet where various organisms live, and it is an important goal of space exploration to search for the possibility of life. The reason why organisms can live on Earth is because of water, air, appropriate temperature, magnetic field, etc. The biosphere of the Earth affects the surface, atmosphere, water quality, etc., and provides the resources and environment necessary for organisms to live. The Moon is the only natural satellite of the Earth, located an average of 384,000 kilometers from the Earth. The Moon is a terrestrial planet, and its surface is made up of rocks and impact craters. The Moon has a very short revolution period of 27 days and a rotation period of 27 days due to the Sun's gravity. The Moon has almost no atmosphere, and the surface temperature is very extreme, ranging from -233 degrees Celsius to 123 degrees Celsius. The Moon has a weak magnetic field and a thin atmosphere with a tail formed by solar wind. The Moon has differentiated into a high-density metallic core made of low-density materials. The core of the Moon occupies 2% of the total volume and is presumed to be in a molten state. The mantle of the Moon occupies 83% of the total volume and is divided into the upper mantle and the lower mantle. The crust of the Moon occupies 15% of the total volume and is divided into continental crust and oceanic crust. The Moon plays an important role in stabilizing the Earth's axial tilt, generating tidal forces, and affecting the Earth's seasonal and climate patterns. The Moon shows various phases such as waxing and waning, crescent and gibbous, depending on the change in position of the Earth and the Moon. The Moon is the only extraterrestrial body that humans have directly explored, and from 1969 to 1972, 12 astronauts landed on the Moon 6 times, analyzed the surface materials and atmosphere, and explored the possibility of life. Mars is the fourth planet in the solar system, located an average of 228 million km from the Sun. Mars is a terrestrial planet, and its surface is made up of rocks and impact craters. Mars is known as Mars in the West, named after Mars, the god of war in Roman mythology, because of its reddish color. In the East, it is called Mars or Hyungokseong, using the character for fire. Mars has a very short revolution period of 687 days and a rotation period of 24 hours and 37 minutes due to the Sun's gravity. Mars is the only planet in the solar system that rotates in the opposite direction of the clock. This means that a day on Mars is longer than a day on Earth, and the Sun rises in the east and sets in the west. Mars has almost no atmosphere, and the surface temperature is very extreme, with 20 degrees Celsius during the day and -73 degrees Celsius at night. 95.97% of Mars' atmosphere is carbon dioxide, and the rest is mostly nitrogen and argon. Mars' atmosphere creates a greenhouse effect that traps solar radiation and raises the temperature to extreme levels. Mars has differentiated into a high-density metallic core made of low-density materials. The core of Mars occupies 42% of the total volume and is presumed to be in a molten state. Mars is the planet in the solar system with the least axial tilt, so there are hardly any seasons. Mars has the highest mountain in the solar system, Olympus Mons, and the largest canyon, Valles Marineris. Mars has two small satellites, Phobos and Deimos. Mars shines red in the night sky and can be easily observed with the naked eye. Its apparent magnitude is -3 + 1.6, making it the fifth brightest celestial body in the sky after the Sun, Moon, Venus, and Jupiter. Mars is the most difficult planet to explore in the solar system, and so far 6 spacecraft have visited Mars. In 1965, the American Mariner 4 made the first close flyby of Mars, photographing 45% of Mars' surface and measuring its atmosphere and magnetic field. In 1971, the Soviet Mars 3 attempted to land on Mars, but communication was lost 14.5 seconds after landing. In 1976, the American Viking 1 and 2 landed on Mars, analyzed the surface materials and atmosphere, and explored the possibility of life. In 1997, the American Pathfinder landed on Mars and deployed a small rover, Sojourner, to investigate the rocks and soil on the surface. In 2004, the American Spirit and Opportunity landed on Mars, analyzed the minerals, rocks, and soil on the surface, and studied Mars' past and present environment, the possibility of life, etc. In 2012, the American Curiosity landed on Mars, analyzed the minerals, rocks, and soil on the surface, and studied Mars' past and present environment, the possibility of life, etc. In 2016, the European Space Agency and Russia's ExoMars attempted to land on Mars, but failed. In 2018, the American InSight landed on Mars and measured Mars' internal structure and seismic activity. In 2021, the American Perseverance and China's Tianwen-1 landed on Mars, analyzed the surface materials and atmosphere, and are exploring the possibility of life. I will briefly explain about the asteroids between Mars and Jupiter. Between Mars and Jupiter, there is a disk-shaped region where millions of small and irregular solid celestial bodies exist. These celestial bodies are called asteroids, and they are distributed in this region called the asteroid belt or main asteroid belt. The asteroids in the asteroid belt are residual materials left from the formation process of the solar system, and they can become meteorites that can fall on Earth. The mass of the asteroid belt is about 4% of the Moon, and the largest asteroid is the dwarf planet Ceres, with a diameter of about 950 kilometers. Asteroids can be classified into carbonaceous, silicate, and metallic, and they can also cause orbital resonance due to the gravitational perturbation of Jupiter. The challenge of unfolding dreams into starlight, an endless adventure towards the mysteries of the universe. Enchanted by the blue flow of the Milky Way, our steps led by the song of the stars. Unraveling the hidden secrets of the galaxy, the courage to challenge the puzzle of the universe. A journey that began at the edge of the Milky Way, our dreams blooming in the infinite universe. The stage of the universe where starlight dances, the fruits of challenge are always where we've run to. Ordinary things become special moments, our challenge to set off in search of the mysteries of the universe. The mystery of the cosmos, an infinite challenge. Jupiter's brilliance, Saturn's beauty unfold. Neptune's icy labyrinth, a dance in the dreamy realm of Uranus. A kingdom of blue dreams, Neptune's serene charm. Jupiter's golden snowfall from azure eyes. Ice-draped elegance in Saturn's ringed dance. Uranus smiles mysteriously with poised grace, while Neptune is enveloped in a blue misty embrace. Satellites waltz in the cosmic unknown. Triton's ice volcanoes, Titania's graceful ballet. Miranda harbors secrets within its petite frame. Oberon exudes elegance in silent repose. Each ring shining in the infinite cosmos. The moment reflected in our eyes is the grander happy ending. The mysteries of the solar system are endless. The universe's smile embraces our dreams. Today, in the Introduction to Astronomy Part 3, we delve into Jupiter, Saturn, their moons, Uranus, and Neptune. Likes and subscriptions greatly support video production. Jupiter is the largest planet in the solar system, composed mainly of hydrogen and helium gases. It is located at an average distance of 778 million kilometers from the Sun, and it takes approximately 12 Earth years to complete one orbit around the Sun. Jupiter is known for having the most extensive system of moons in the solar system, with a total of 79 discovered so far. These moons vary in size, shape, composition, and activity, influenced by Jupiter's gravity and magnetic field. The most famous moons of Jupiter are the 4 Galilean moons, first discovered by Galileo Galilei in 1610. These moons exhibit diverse features and are the largest and most prominent among Jupiter's satellites. The Galilean moons are as follows. Io, the closest Galilean moon to Jupiter, with a diameter of 3,642 kilometers. Io is the most volcanically active body in the solar system, featuring hundreds of volcanoes that spew sulfur and sulfur compounds, coloring its surface in shades of yellow and orange. Europa, the second closest Galilean moon with a diameter of 3,121 kilometers. Europa has an icy surface, and beneath the ice, there is a strong possibility of a large ocean composed of liquid water. Europa is considered one of the most intriguing bodies in the solar system for its potential to harbor environments suitable for life. Ganymede, the third closest Galilean moon and the largest moon in the solar system, with a diameter of 5,262 kilometers, larger even than the planet Mercury. Ganymede is composed of a mix of ice and rock, possessing its own magnetic field. Its surface displays a combination of ancient and more recent ice features, including craters, grooves, and mountain ranges. Callisto, the farthest Galilean moon from Jupiter, with a diameter of 4,821 kilometers. Callisto boasts one of the oldest surfaces in the solar system, with minimal changes over the past 4 billion years. Composed of ice and rock, Callisto's surface is marked by numerous craters. There is also a possibility of a subsurface ocean beneath its icy crust. Saturn is the sixth planet from the Sun in our solar system, renowned for its beautiful rings and diverse moons. Discovered by Galileo Galilei in 1610, Saturn is the second largest planet in our solar system. It has a mass approximately 95 times that of Earth and a diameter of about 120,536 kilometers. Saturn is primarily a giant gas planet composed mainly of hydrogen and helium, lacking a solid surface. Instead, its interior consists of a compressed core made of hydrogen and helium at high pressures and temperatures. The atmosphere of Saturn is primarily composed of hydrogen and helium, with small amounts of methane, ammonia, methane hydrate, water vapor, and other substances. The thick cloud layer in the atmosphere, predominantly made up of ammonia ice clouds, gives Saturn its distinctive yellowish appearance. Saturn is famous for being one of the ringed planets. Its rings are made up of numerous small ice and rock particles, and the most well-known rings are named A, B, C, D, and F. These rings encircle Saturn in a disk-like fashion, maintained by the gravitational forces and the interactions with its moons. Saturn's rings are the largest and brightest in the solar system, providing valuable insights into Saturn's history and the planetary formation process. Saturn has been extensively studied by various space probes. NASA's Cassini-Huygens spacecraft arrived in orbit around Saturn in 2004, conducting thorough investigations of Saturn and its moons. The Cassini spacecraft provided valuable information about Saturn's rings, moons, and atmosphere. Additionally, research on Titan, one of Saturn's moons, was a significant focus. The European Space Agency's Huygens probe made history by directly studying Titan's surface. Saturn remains a mysterious planet surrounded by beautiful rings and diverse moons, making it a crucial target for space exploration and research. Saturn's moons are among the most diverse and intriguing objects in the solar system, with 145 discovered so far, 13 of which have diameters exceeding 50 kilometers. These moons exhibit variations in size, shape, composition, and activity, influenced by Saturn's gravity and magnetic field. Some notable Saturnian moons include Titan, the largest moon of Saturn, and the second largest moon in the solar system, with a diameter of 5,150 kilometers. Titan has a substantial atmosphere primarily composed of nitrogen and methane. Its surface features lakes and rivers of liquid methane and ethane, along with geological formations made of ice and organic materials. Rhea, the second largest moon of Saturn, with a diameter of 1,527 kilometers. Rhea is composed of ice and rock and has a surface with bright and dark regions, including craters. It lacks its own magnetic field, and is exposed to Saturn's radiation. Iapetus, the third largest moon of Saturn, with a diameter of 1,471 kilometers. Iapetus has a distinctive two-tone surface, featuring a dark hemisphere covered in organic material likely originating from Titan, and a bright hemisphere composed of ice. Dione, the fourth largest moon of Saturn, with a diameter of 1,123 kilometers. Dione has a surface marked by craters, canyons, and ice volcanoes. There is a possibility of a subsurface ocean beneath its icy crust. Tethys, the fifth largest moon of Saturn, with a diameter of 1,062 kilometers. Tethys displays various surface features, including craters, canyons, and mountain ranges. Notable landmarks include the large crater Odysseus and the massive canyon Ithaca Chasma. Enceladus, the sixth largest moon of Saturn, with a diameter of 504 kilometers. Enceladus is an icy moon that exhibits active geysers erupting from its south polar region. These geysers are the source of material for Saturn's E-ring. Mimas, the seventh largest moon of Saturn, with a diameter of 396 kilometers. Mimas is known for its prominent Herschel crater, which gives it the appearance of the Death Star from Star Wars. It has a surface with craters, canyons, and mountainous features. These diverse moons of Saturn provide valuable insights into the planetary formation processes, and the conditions that exist in the outer regions of our solar system. Ongoing exploration and research are expected to unveil more secrets about Saturn and its intriguing moon system. Uranus is classified as an ice giant in the solar system, composed primarily of ice and gas. However, the exact internal structure of Uranus is not well known. It mostly has an atmosphere consisting of hydrogen and helium, along with various compounds such as methane, ammonia, and water vapor. Uranus has at least 27 known moons, with Titania, Oberon, Umbriel, Ariel, and Miranda being the 5 major moons. The moons of Uranus exhibit diverse characteristics in terms of size, shape, composition, and activity, influenced by Uranus's gravity and magnetic field. Let's take a closer look at the moons of Uranus. Titania, the largest moon of Uranus, with an estimated diameter of about 1,578 kilometers. Titania is composed of ice and rock, featuring a surface with craters, canyons, and mountain ranges. There is a possibility of a subsurface ocean beneath the ice on Titania. Oberon, one of the larger moons of Uranus, second in size only to Titania. Oberon is composed of ice and rock, displaying various geological features, such as craters, canyons, and mountain ranges. Oberon is known for the absence of geological activity. Ariel, one of Uranus's larger moons, with a diameter of approximately 1,157 kilometers. Ariel is composed of ice and rock, and its surface exhibits craters, canyons, plains with craters being particularly prominent. Maps of Ariel have been created, showing similarities to Earth. Umbriel, one of the larger moons of Uranus, with a diameter of about 1,170 kilometers. Umbriel is composed of ice and rock, and its surface has a dark appearance. There is a possibility of a subsurface ocean beneath the ice on Umbriel. Miranda, among the smaller moons of Uranus, with a diameter of approximately 472 kilometers. Miranda has unique geological features, including deep canyons, cliffs, craters and plains. Miranda has a singular structure compared to other moons. These diverse moons of Uranus provide valuable insights into the moon's geological processes, surface conditions, and potential subsurface oceans. Ongoing exploration and research aim to uncover more about the mysteries surrounding Uranus and its intriguing moon system. Neptune is the furthest planet in the solar system, comprised of ice and gas, and was first discovered by William Herschel in 1781. It was named after the Roman god of the sea, Neptune. Neptune is located approximately 4.5 billion kilometers away from the Sun and takes about 165 Earth years to complete one orbit around the Sun. Its atmosphere is mainly composed of hydrogen and helium, with small amounts of methane, ammonia, water vapor, and thick clouds of ammonia ice, giving Neptune its distinct blue color. Neptune has a total of 14 known moons. The largest and brightest moon is Triton, occupying 99.5% of Neptune's mass. Triton is unique among Neptune's moons as it orbits in the opposite direction and features ice volcanoes and nitrogen geysers, making it one of the few geologically active natural satellites in the solar system. The other moons of Neptune were mostly discovered in the 20th century and are named after characters from the works of William Shakespeare and Alexander Pope. These moons vary significantly in size, shape, composition, and activity, influenced by Neptune's gravity and magnetic field. Neptune possesses a faint ring system composed of ice and dust particles. The existence of the rings was confirmed in 1989 by the Voyager 2 spacecraft. Unlike Saturn's bright rings, Neptune's rings have a dark color, possibly due to changes in the material composing the rings caused by solar radiation. Being the coldest planet in the solar system, Neptune has a surface temperature of around -218 degrees Celsius. However, its interior is hot and highly pressurized, with a presumed liquid core. Neptune harbors the strongest winds in the solar system, with storms reaching speeds of up to 2,100 kilometers per hour. The planet experiences seasons due to its axial tilt, similar to Earth, but each season lasts for approximately 40 Earth years. Neptune, being a distant and enigmatic planet not visible to the naked eye, has only been visited by the Voyager 2 spacecraft in 1989. This mission provided valuable information about Neptune and its moons. Neptune offers intriguing insights into the primitive history and planetary formation processes of the solar system, and further exploration and research are expected to unveil more mysteries surrounding this distant gas giant. Mystery of the cosmos, an infinite endeavor. Jupiter's radiance, Saturn's beauty. Neptune's icy maze. A realm of azure dreams for Neptune. Each ring shining in the boundless cosmos. The moment reflected in our eyes is the grand happy ending. The smile of the universe embraces our dreams. Thank you for subscribing and watching. Sailing the blue seas like Magellan of old. The courage of the age of discovery, dreaming of humanity. Beyond Pluto and the Kuiper Belt's border. Embarking on a journey at the speed of light to Proxima Centauri. Following the shining stars of a trinary system. Unlocking the door to alien planets. Our footsteps traverse the treacherous cosmos. Dreams of diverse hues scattered across the infinite universe. Dancing to the rhythm of the stars and singing. Exploring the mysteries of alien planets with a spirit of challenge. The courage of humanity soaring at the speed of light. An endless longing for the mysteries of the universe. In this era of adventures, sailing towards those dreams. Anticipating the day when we reach out and touch them with our own hands. Today, in Astrophysics Lecture 15, we will delve into the challenges and dreams of humanity regarding Pluto, the Kuiper Belt, the speed of light, and more. Your subscriptions and likes greatly support video production. Here's a brief explanation of Pluto and the Kuiper Belt in English. Pluto was known as the ninth planet in the solar system, but it was reclassified as a dwarf planet in 2006. Pluto is primarily composed of ice and rock, with a diameter of about 2,376 kilometers. Pluto is on average 3.95 billion kilometers away from the Sun, and it takes about 248 years to orbit the Sun once. Pluto has a very fast rotation speed, with a day lasting only about 6 hours. Pluto has 5 moons, the largest of which is Charon. The Kuiper Belt is a disc-shaped region of the solar system located beyond the orbit of Neptune. It extends from about 30 to 55 astronomical units. 1 astronomical unit is the average distance between the Sun and the Earth, about 150 million kilometers from the Sun. The Kuiper Belt contains millions of icy objects thought to be remnants left over after the formation of the solar system. Some of these are classified as dwarf planets or comets. The most famous object in the Kuiper Belt is Pluto, and there are also Eris, Makemake, Haumea, and others. The Kuiper Belt and the Oort cloud are collections of icy objects in the outer regions of the solar system. However, the two regions differ in distance, shape, and composition. The Kuiper Belt is a disc-shaped region located beyond the orbit of Neptune, extending from about 30 to 55 astronomical units. 1 astronomical unit is the average distance between the Sun and the Earth, about 150 million kilometers from the Sun. The Kuiper Belt contains millions of icy objects thought to be remnants left over after the formation of the solar system. Some of these are classified as dwarf planets or comets. The most famous object in the Kuiper Belt is Pluto, and there are also Eris, Makemake, Haumea, and others. The Oort cloud is located within the gravitational field of the solar system, and can sometimes be drawn into the inner solar system by the gravity of external objects. The Oort cloud is a much more distant space region thought to extend from about 5,000 to 100,000 astronomical units from the Sun. Unlike the Kuiper Belt, which is thought to be a relatively flat and uniform spatial region, the Oort cloud is thought to be a spherical cloud of icy objects surrounding the solar system. The Oort cloud is estimated to contain about 1 trillion objects, most of which are believed to be the source of long-period comets. The Kuiper Belt and the Oort cloud play an important role in understanding the history and structure of the solar system. They can also help explore the possibility of extraterrestrial life. The closest galaxy to the solar system is not Alpha Centauri, but the Canis Major dwarf galaxy. This galaxy is a satellite galaxy of our Milky Way, and it's only about 25,000 light-years away from the solar system. Alpha Centauri is not a galaxy, but a triple star system, and it contains the closest stars to the solar system. These stars are distinguished as Alpha Centauri A, B, and C, with C also known as Proxima Centauri. There are 2 planets discovered in the Alpha Centauri system. One is the rocky planet Proxima b, which orbits Proxima Centauri, and the other is the gas planet Alpha Centauri bb, which orbits Alpha Centauri b. Proxima b is the closest exoplanet to the solar system, and has a size and mass similar to Earth. This planet is at an appropriate distance from its star, so it is located in the habitable zone where liquid water could exist on its surface. Alpha Centauri bb, discovered in 2012, is the first planet discovered in the Alpha Centauri system. This planet has a mass 1.13 times that of Jupiter and is very close to its star, resulting in a surface temperature of about 1,200 degrees Celsius. Theoretically, the only particles that can achieve speeds close to the speed of light in space are those without mass. For example, photons, which are energy quanta of electromagnetic waves, move at exactly the speed of light in a vacuum. Also, neutrinos, which have a very small mass, are believed to be able to reach almost the speed of light. However, according to the theory of special relativity, matter with mass cannot reach the speed of light because it would require an infinite amount of energy to do so. But, matter with mass can reach speeds up to a few percent of the speed of light. For example, high-speed spacecraft can reach speeds of about 0.1% of the speed of light. Also, particles accelerated in high-energy particle accelerators can reach speeds of more than 99.999% of the speed of light. Therefore, the only matter that can achieve speeds close to the speed of light in space is either massless or has a very small mass, and matter with mass cannot reach the speed of light due to energy limitations. Accelerating to more than half the speed of light is currently impossible with our technology. According to the theory of special relativity, a body with mass cannot reach the speed of light, and the closer it gets, the more energy is required. Therefore, to accelerate to more than half the speed of light would require a tremendous amount of energy, and no method of supplying that energy has yet been discovered. However, theoretically, there could be ways to accelerate to more than half the speed of light. For example, some researchers argue that using a shortcut in space called a wormhole could allow for faster than light travel. Also, some researchers argue that using a hypothetical spaceship engine called the Alcubierre drive could allow for faster than light acceleration. However, these theories have not yet been experimentally proven and may contradict the basic laws of physics. In conclusion, accelerating to more than half the speed of light is currently impossible, and even if it were possible, it would be very difficult. The Alcubierre drive is a hypothetical spaceship engine proposed in 1994 by American physicist Michael Alcubierre. This engine works by installing a device that distorts space in front of and behind the spaceship, so the spaceship itself does not move, but the surrounding space is pulled forward and pushed back to allow for faster than light travel. This method is claimed to circumvent the prohibition of faster than light speeds in the theory of special relativity. However, the Alcubierre drive is still just a theoretical model with no feasibility. This is because the engine requires a material with a negative energy density to operate, and such a material has not yet been discovered. Also, the Alcubierre drive may contradict the basic laws of physics in that it does not emit gravitational waves predicted by the theory of general relativity. Therefore, the Alcubierre drive is currently an unscientific hypothesis and has many problems for actual implementation. There are several theories about moving faster than the speed of light. For example, some researchers claim that using a shortcut in the universe called a wormhole can allow for travel faster than the speed of light. Also, some researchers claim that phenomena such as teleportation or quantum entanglement can transmit information faster than the speed of light. However, these theories have not yet been experimentally proven and may contradict the basic laws of physics. Therefore, moving faster than the speed of light is currently impossible, and even if it were possible, it would be very difficult. Nuclear fusion plasma, antimatter, and various other engines are all potential future spaceship engines that can reach speeds close to the speed of light. However, it is currently very difficult to actually implement or test these engines. The nuclear fusion plasma engine uses a nuclear fusion reaction to eject plasma at high speed to gain thrust. This engine is expected to reach about 10% of the speed of light. The antimatter engine uses the tremendous energy released when matter and antimatter collide to gain thrust. This engine is expected to reach speeds greater than 50% of the speed of light. Various other engines are various theoretical models, and there are researchers who claim that they can move faster than the speed of light using wormholes, Alcubierre drives, teleportation, etc. However, these engines have not yet been experimentally proven and may contradict the basic laws of physics. Therefore, nuclear fusion plasma, antimatter, and various other engines are all potential future spaceship engines that can reach speeds close to the speed of light, but the possibility of realization is currently low. Important navigation technologies that made the age of discovery possible were the triangular sail and the compass. The triangular sail allowed for sailing against the wind, and the compass provided accurate direction. These technologies enabled Europeans to discover and trade with new lands such as Africa, America, and Asia. A solar sail spaceship gains propulsion by utilizing the radiant energy of the sun. The principle of a solar sail spaceship is to spread the sail and move forward by reflecting sunlight and reacting. Since a solar sail spaceship does not require fuel and can reach speeds close to the speed of light, it is expected to be useful for future space exploration. There are various ways to equip an engine on a solar sail spaceship. For example, solar panels can be installed on the sail to generate electricity, and that electricity can be used to operate ion engines or electromagnetic engines. Alternatively, additional propulsion can be obtained by shooting lasers or particle beams at the sail. However, these methods are still in the experimental stage, and there are many challenges and problems to actually implement them. Therefore, while it is possible to apply the navigation technology of the age of discovery to the implementation of a solar sail spaceship, it has not yet been fully realized. For more details, please refer to the following links. It seems that this could increase the speed of the solar sail spaceship. However, there are many problems and challenges to do so. For example, the following issues exist. Installing solar panels outside the Earth on multiple planets is very costly and technically difficult. Especially, it is even more difficult to install on planets outside the solar system. Precise control and aiming are required to shine sunlight on a solar sail spaceship. Because the orbit and direction of the solar sail spaceship can change, it is not easy to keep shining sunlight. Shining sunlight on a solar sail spaceship will heat it. If heat accumulates excessively, the structure of the solar sail spaceship can be deformed or destroyed. Therefore, an effective way to dissipate heat is needed. Shining sunlight on a solar sail spaceship will exert force on it. If the force accumulates excessively, the orbit of the solar sail spaceship can become unstable or escape. Therefore, an effective way to control the force is needed. Therefore, while it is theoretically possible to install solar panels outside the Earth on multiple planets and shine them on the solar sail spaceship, it is very difficult in reality. In the wake of Magellan's legacy, a cosmic odyssey unfolds. Across the vastness, past Pluto, and through the Kuiper belt it holds. Venturing into realms at the speed of light. Beyond the trinary stars, towards Proxima Centauri's height. A dance with celestial bodies in a distant cosmic ballet. Our quest for knowledge, a journey that knows no delay. Through the cosmic winds and the boundless sea of stars. We explore alien realms, removing the veils that are far. Braving the challenges, fueled by an unyielding dream. Humanity's spirit, a radiant and constant gleam. Probing the secrets of planets yet unknown. A symphony of exploration, a melody to be sown. At the speed of light, our aspirations soar. A yearning for the universe, forever seeking more. In this age of cosmic dreams and fearless might, humanity reaches for the stars, a celestial flight. So, let us sail through the cosmic sea. Towards a future where the unknown shall be free. Thank you for subscribing and watching.